Oh, hey. So, why do I have two cameras taking photos of me instead of just one? Well, I'm not a male model. Although, I could be. I'm actually demonstrating a concept used on NASA's stereo satellite mission. It's not music in space. It's a different way to see the sun. The details next on Real World.
3, 2, 1, 0, and liftoff of the Delta II rocket with stereo, giving us a three-dimensional look at the physics of our sun.
In 2006, NASA launched 2 satellites as part of their Solar Terrestrial Relations Observatory mission. STEREO for short. The main goal of STEREO is to increase our understanding of the sun, mainly the powerful solar eruptions that can send 1 billion tons of the sun's outer atmosphere into space and towards Earth and beyond.
The main thing that we're studying are things called coronal mass ejections, or CMEs.
Terry Kuchera is the STEREO Deputy Project Scientist at the NASA Goddard Space Flight Center.
CMEs are these giant clouds of gas that blow off the sun, and they actually blow out into the solar system, and they can reach the Earth and affect us here. They affect spacecraft and communications and power systems, so there are practical reasons to wanting to study and understand these, in addition to actually just being interesting because the sun is a really dynamic place.
CMEs have incredible effects on Earth. For instance, they can wreak havoc on satellites with microelectronics on board, affecting cell phones and GPS systems here on Earth. The CMEs can reset memories or wipe out power supplies on these satellites. But if we know they're coming, the satellites can be switched to safe mode until the solar storms pass. So, getting back to stereo, remember when I said NASA launched 2 satellites? Well, the purpose of having 2 is to give us a stereo view of the sun. The first satellite is in orbit ahead of the Earth, and the second is behind it. This gives scientists a 3-dimensional view of the sun.
That helps us understand better what the actual structures we're seeing are. I mean, people take this for granted. I mean, human beings, most of us have 2 eyes, and that's actually how we keep from doing things like bumping into things and catching things. If you stick a finger up in front of your eye and look at something in the distance, say that tree over there, and you go back and forth with your eyes, you'll see your finger is jumping back and forth against the thing in the distance. And that just shows that you actually get 2 different views from your 2 eyes. And your brain can synthesize that to tell you information about how close different things are.
You need both eyes to be efficient. NASA's stereo mission works the same way.
Mathematics is really key to what we're doing with stereo, and understanding angles and even trigonometry is very important. And the basic idea is things don't look the same from different points of view, and motions don't look the same from different points of view. Having 2 points of view allows you to put the information looking this way with the information looking that way and actually be able to tell where it is. And that involves geometry and angles, and it's really tied into what we're doing.
That's why tickets in the end zone of a football game are less expensive than tickets at the 50-yard line. If you are watching from the 50-yard line, you can get a great sense of how fast a player is going and the distance he is covering. But from the end zone, not so much. So by getting the right perspectives, the stereo satellites are able to give scientists good data to judge the speed and direction of CMEs.
When we have 2 spacecraft, we can use those to figure out better how things are moving through space, how fast things are moving, what direction they're going, how they're shaped. And all those things can help us understand what sort of structures on the sun can lead to these explosions, how they're moving through space, how quickly they're liable to get to Earth.
Try the math yourself. Experiment with different angles and points of reference. You'll get a much better idea of how stereo helps us understand the sun by showing us a 3-dimensional view of our universe.